3 is going to, first thing we're going to do is we're going to draw on your experience from Algebra 1. Back in Algebra 1, you learned how to solve systems of linear equations, right? You solved them 3 ways. The first way that you solved them was by graphing, right? Where you would find the intersection of 2 points, right? These points had the coordinates, or the intersection of 2 lines at one point had the coordinates x, y. That was the solution to your system, right? The other way that you learned was by elimination, yeah? Where you would add 2 equations together to get one of your variables to go away. The other method that you learned was substitution, where you would take and you would solve for one variable and then plug it back in. So we're going to use a combination of both. We're actually going to use both methods for you guys, in a combination, I guess, in order to solve these things. So this first one lends itself really well to elimination. So let's go ahead and solve this one by elimination. I'm going to go ahead and take equation 1, and I am going to subtract equation 2 from it. 2x minus 2x is 0. 3y minus y, right, is going to be 2y. And 7 minus 3 is 4. So we get that y is equal to 2 when we divide both sides by 2. Now that I know what y is, I'm going to go ahead and plug it back in equation 2. I'll go ahead and substitute 2 in for y right there. And then I'll subtract 2 from both sides. Divide both sides by 2. And I get that x is equal to 1/2, which means that the solution of this is the ordered pair 1/2, 2, right? In other words, these two things are lines, and they intersect at the points 1/2, 2. Beautiful. That's pretty nice. All right, let's do it again, except for now, let's use the substitution method. Okay. Boom. Hey, when I'm going to use the substitution method, I want to find the equation that has, I want to find, right, the one that has a coefficient of 1, the variable, I should say, that has a coefficient of 1, and solve it for that, right? Because that's going to be less work. I like doing less work. I don't want to do more work. Who wants to do more work? Maybe Sydney, but that's it. All right. So I'll go ahead and take equation 2. And I'll solve it for x. So I'll subtract 2, I'll add 2x to both sides. I apologize if that 2 looks wonky. I'm going to fix it. Boom. Bam. Now that I know what y is, I'm going to take that and I'm going to substitute it back in. Now be careful, okay? I can't substitute this back in equation 2 because I'll get weirdness, right? All my variables, everything will go away. I'll wind up with 0 equals 0, and it's going to be strange. So if I solve equation 2 for y, that means I have to plug that back into equation 1. So y is 2x plus 2 equals 4. And now I'm going to distribute my 2, so 5x minus 4x. And the whole point of doing this was to get my y to go away. Isn't that right? Let's see. So I get x minus 4 equals 4 when I combine my terms. And then I'll add 4 to both sides. I get x is equal to 8. Boom, got one of them. Now that I know what x is, I'll plug it back in. Is this starting to ring a bell? You're not remembering this from algebra now? So y is 18. So our solution to this is the ordered pair x, or 18. Okay, so now let's step it up a notch. know how much you all love chemistry. Okay, so we have a chemistry problem. So, hey, I know you guys do math in your chemistry classes a lot. Now you're going to do chemistry in your math class. Yeah. All right, so what do we got to do? We need to create 120 milliliters of a solution that's 30% acidic. All right, we're going to create it by mixing 20% acidic solution and a 45% acidic solution. We need to know how many milliliters each we should combine to create a 30% solution. So the easiest part of this to set up, right? First of all, let's let X be our 20% solution and Y be our milliliters, I should say, of our 45% solution. So then it would be the case that X plus Y should be 120, right? Because we have so many milliliters of one and so many milliliters of another to combine to get a total of 120 milliliters, right? Okay. The next part is weird, right? Because now I need to figure out the 30% solution, right? So if I was to set this up, right, say 0.2 times X plus 0.45 times Y equals 36. Let's explain that first. I wrote it down. Let me explain it. Or not first, but after I write it down. So, 36. Yeah, so where does the 36 come from? All right. So I want a 30% solution, yeah? So I need to add some amount of millimeters of 20%, right? To some amount of milliliters of the 45%. In order to get a 30% solution, well, 30%, so think about it. I have 120 milliliters total, right? I want 30% of it to be acidic. So I got the 36 by taking 30% of 120. So I multiplied 120 times 0.3, and I got 36. Yeah? So that would be the 30% of 120 milliliters. Yeah? All right? So I want to add these together so that I get 36 milliliters, which would make it 30% acidic. Cool? Yeah? So we got to solve this now. That for me is the hard part. This right here, the 36, this right here was the difficult part for me to figure out. I understood that this is what my system of equations need to look like, but I couldn't figure out what number needed to go. It took me a little while. I had to think about it. So. Okay. So, what should I do? I think I would like to take equation 1, right? I'll always number these. I'll take equation 1 and solve it for y, I guess. So okay, equation 1, I'll use substitution method on this one. So that'll be 120 minus x. Now I'll substitute that into equation 2. So I have 0.2 x plus 0.45, and I'm going to substitute now instead of y. I'll put 120 minus x equals 36. Now it's time to solve this equation. We have one variable now, which is really nice. And 45% of 120 is 54. Minus 0.45. X equals 36. Now it's time to combine like terms. So I'm gonna have 54, and then this is gonna be minus. It's probably gonna be something like negative 25x, 0.25x. equal to 36. And then I'm subtracting 54 for both sides. That's going to give me, proper 18. And divide both sides by 0.25, so a quarter of 18, right? Something is wrong. Multiply everything by -4. I mean, I could. I think I made a mistake somewhere. So we'll divide 18 by 0.25. There we go. That's not true. All right. Let's go ahead and now substitute 72 in equation 1. And we will go ahead and subtract 72 from both sides. And we will get that. What? That y is equal to 48. Right? All right, so that means that we need 72 milliliters of the 0.2 of the 20% solution, and we need 48 milliliters of the 45% solution. There we go. So we did a little chemistry in math class. Now let's do something really new. Ready? Okay. Hey! I want to introduce you guys to a new variable. Its name is Z. What in the world does that even mean? Alright, check it out. What we've done is we've now entered the third dimension, mathematically speaking. Check it out. Imagine this. Imagine this. Sometimes it's weird for people to imagine. You take your y-axis. So this is your y-axis, right? You take it, boom, you plop it down on its back, and then z is coming right out the middle. See that? See it? Yeah. That's what the picture looks like. So that's what z is. Z is the third dimension. It's height, right? You have length, width, and then height. Yeah? So just so you can get an idea of what's going on, each one of these equations over here, I'm going to go ahead and number them right away, 1, 2, and 3. Each one of them is a line in 3 dimensions. It's a line in 3 dimensions. And what we're going to find when we solve this for x, y, z, we're going to find the point where the 3 lines cross. All right? Let's go ahead and use elimination method first, okay? So we can still use all of these methods that we had before. We can use substitution, elimination. We could graph them if we wanted to, but that would be maybe a little weird. So let's just go ahead and use elimination or substitution on these. And also, you can use a combination of the two. So, what should I do? I think I'm going to go ahead and I'm going to do equation 1 plus equation 3. Okay? That's going to help me to get rid of my z. And that's going to be my goal, all right? My goal is always going to be to get rid of one of my variables, right? Because like I said, mathematicians are lazy. And they see 3 variables, and they're like, nah, don't really want to do that. I'd rather solve with 2 variables. And so they'll make it that way, and that's what we'll do as well. So what I want to do then is I want to do 2x plus 3y minus z equals 5 plus x plus 4y plus z equals 12. I'm going to add those together. That will give me a new equation, 3x plus 7y equals 17. Yep. I'm going to call that equation 8. Sorry, it's a new one that we made. Okay, now we need another one. So let's go ahead and add equation 2 plus equation 3. So we'll do equation 2. I kind of feel like doing something a little different. Let's do equation 1 times negative 1. Now you could do equation 2 times, equation 2 plus equation 3, and you would get rid of your z. I just want to show you that you can also manipulate these things, right? I can multiply equation 1 by negative 1 to get that to be a, what did I want to do? I wanted to, add it to equation 2, I apologize. That works better. All right, sorry. Just wanted to show you that you're allowed to manipulate these things by multiplying through by one entire number. So I'm going to take equation 1 and multiply by negative 1. So that's going to be negative 2x minus 3y plus z equals negative 5. And I'm going to add that to equation 2, which is 4x minus y minus z equals negative 1. Go ahead and add those. That will give me minus 4y equals negative 6. Awesome. We'll call this equation B. Now, I need to solve either equation B or equation A. Yes?
Why is it like that one equals 1 plus 2 with like, I guess why did you change the signs on me?
I changed them so that when I add my z's, they go away. Like I said, I could have just done equation 2 plus equation 3, right? And it would have been just as good, but I wanted to show you that if it wasn't the case, like I can also multiply through by one number, right? In order to get my result. So I either can solve equation A or equation B for either x or y. I'm going to choose B because it looks like it's going to be nicer, right? Equation A has a 17 and a 7 and a 3. It's filled with prime numbers. Yeah, right? Equation B there is filled with nice numbers that are divisible by 2. So I can solve this one for x, and it'll give me something nice. Like I said, when you're doing these, thinking ahead makes all the difference in the world. If you just try to plug through it and just barrel your way through it without thinking about it first, it's going to get messy. You can do it that way, you can take a lot of extra steps. So I'm going to solve this one for 2x. And I get some nice numbers, right? If I was to solve this, if I was to do that with equation 8, I would wind up with a bunch of fractions. And I don't really want to substitute fractions back in if I don't have to. So now that I have this new equation, I know what x is. I can plug that back into equation A. Bam. I'm going to go ahead and distribute. All right. I'll combine like terms. And I get the negative 9 plus 13. Everything as it should be. Second. 2. Alright. So I'll go ahead and add 9 to both sides. So y equals. Alright, so now that I know what y is, I will plug that into this equation. So x is going to be 4 minus 3, so x is 1. Alright, so now that I know what x and y are, I'm going to go ahead and plug them into, I don't know, let's do equation 1, okay? So equation 1 says that I have 2 times 1 plus 3 times 2 minus z equals 5. So I just need to figure out what the z is. I need to solve this guy for z. So that's 2 plus 6 minus z equals 5. So this gives me 8 minus z equals 5. So then negative z is going to be equal to negative 3, which is the same thing as saying that z is 3. Hey, 1, 2, 3. Guys, we'll express this as the order triple, where this is x, and this is y, and this is z. Alright? If you have x, y, and z, you should express your answer as an order triple. Because what this is a set of coordinates in our three-dimensional space. Alright, now we've done one using the elimination method. Let's go ahead and do one using substitution. Okay, let's go ahead and solve this one using substitution method. Okay. I have, let's go ahead and label them first. 1, 2, and 3. Looks like equation 2 has r already gone, right? Oh, and by the way, this is a typo, sorry. This should say 2x, sorry. Not 2x. 2x. When I first looked at this problem and I saw the x there, I went, oh no. That's a really hard problem. And it turns out it's easy. So, what I'm going to do is, since equation 2 has r gone already, I'm going to go ahead and solve either equation 1 or equation 3 for r. Plug it back into the other one, and then I'll have a 2 by 2 system. So, let's go ahead and solve equation 3 for r. So r minus s minus u equals 2. Alright, so that means that r is going to be equal to s plus u plus 2. I'm going to plug that into equation 1. Instead of r, now I have s plus u plus 2 plus 2s minus u equals 8. Okay? Substitution method. Alright, I put that in parentheses just because they don't need to be there. Hey, look at this. An amazing thing just happened. Our u's are going to cancel. Right? I got a positive u, I got a negative u. Positive u, negative u, those are going to go away. I add my s's. That's going to give me 3s plus 2 equals 8. When I combine my like terms. So then we have 3s equals 6 when we subtract 2 from both sides. So s is equal to 2. Well, that was fantastic. Looks like substitution method really worked out for us. Because now, I actually don't have to do what I said, where I was going to substitute that back in. I can go straight to equation 2 and solve that for u. So u is 2. Now that I know what s and u are, I'll go ahead and go to equation 3 and solve for r. Minus s, which is 2, minus u. And there we are. We did it. That one went fairly quickly. All right, let's step it up one notch, a little more. All right. Oops. Right below that, there is a really good problem. Man, this one's awesome. Right? So, the trick with this is, right, they say, hey, find the equation, or a quadratic, right? Obviously, if you were to plot these, they would look like they're in the pattern of a parabola. And you're looking at this, and at first maybe thinking, there's not enough information, right? But if you look at it in this way, that these are an input and an output, right? That I have x equals 1, y equals 6, right? When x equals 3, y equals 20, and when x equals negative 2, y equals 15. And then they've also given you this equation here. It says that y equals ax squared plus bx plus c. Well, now I have actually a y, and I have x's, right? And here's my x, and there's my y. Yeah? So that means that I can come up with a system of equations, right? So I can come up with my first equation in my system of equations by plugging in, or sorry, substituting. If I substitute the right values, that would be better. I'll substitute 6 in for y, and I'll substitute 1 in for x. And so I'll get a plus b plus c. There's our first system. Our first equation in this system. For equation 2, again, I'll substitute 20 in for y, and then I'll substitute 3 in for x. So then my second equation will look like 9a plus 3b plus c. And for equation 3, I'll do the same thing. Y is 15, and x is negative 2. So that gives me the equation 4a minus 2b plus c. So there we go. I have 3 equations, 3 unknowns. It's time to solve them. What shall I do? What would I like to do? Elimination, substitution. I don't know. You like substitution method? Okay. So we could pretty easily get C to go away. I don't know. I honestly think elimination is going to be better. I'm going to take equation 1, and I'm going to multiply it times 2, and then I'm going to add it to equation 3. So that's going to give me 12 equals 2a plus 2b plus 2c. I'm going to add that to 15 equals 4a minus 2b plus c. Add them together. That's going to give me 27 equals 6a plus 3c. We'll call that equation A. All right. Now I can get my b to go away in equation 2 by going ahead and taking equation 1, multiplying it times 3, and then let's do equation 1 times negative 3. Equation 1 times negative 3 plus equation 2. So equation 1 times negative 3 is going to give me negative 18 equals negative 3a minus 3b minus 3c. And we're going to add that to 20 equals 9a plus 3b plus c. So we'll get 2 equals 6a minus 2c. That's nice. I like that. Sorry. The reason why I like that so much is because I can solve this thing for c. We'll call this equation b. I can solve it for c, and I'm going to have nice round numbers, right? What freaks me out is when I get equations and I wind up with a bunch of fractions. Because I'm not freaked out about it, it's just that I have to get ready to hang in there for the long haul and do a bunch of calculations, right? Do a bunch of fractions. It means it's going to take a bit longer to solve. So, but this one is nice, because if I solve it for c, right, I'm going to go ahead and subtract 6a from both sides. And then I'll divide both sides by negative 2. That gives me negative 1 plus 3a equals c. Nice. That's what c is. Okay. Now, I'll go ahead and plug that into, I guess, a for c, and then we'll be able to solve for a, right? So I'm going to take, and I'm sorry they didn't give me quite enough space to do all this work there, but it's okay. So I'm going to take equation A, and I'm going to plug in, or substitute, negative 1 plus 3a for c. Sorry. And that's going to allow me to solve for a. So I have 6a minus 3 plus 9a. Combine like terms. 15a minus 3. So I'll go ahead and, oh no, it's going to be great. I'll add 3 to both sides, and you get 30 equals 15a. So that means that a is 2. Yes, we got our first one. The bulk of our work has been done. So this is still equation B, right? The -1 plus 3a equals c. So I'll take my equation B that I have really simplified, and I'm going to go ahead and plug in or substitute 2 for a, and that'll give me that c is equal to 5. And lastly, I guess I can go all the way back up to equation 1, a plus 6 equals a plus b plus c. So equation 1, 6 equals a plus b plus c. And I'll substitute in a and c. So that's 7. So I get -1 as b. But we're not done. That's not all. They asked us for the equation, right? Yeah? And so that means I need to plug that in. And the equation was y equals, right? It was ax squared plus bx. So that'll be minus x, right? If b is -1. And c was 5. So that is our final answer. Well, I just plugged A, B, and C back into that equation. That's all the way back to the top there. And that is all the fun times we have for you today.